Hi everyone. So Johannes and me are going to give a talk about Neato and Firmware vacuum cleaners. So this is Johannes, and Johannes is my student and Fabian's student, but Fabian is not here. We supervised his master thesis on those vacuum cleaning robots. And I am Jiska. You might know me from hacking all the other things like Fitbit or Broadcom Bluetooth. Ooh. Yeah, I don't know. Now, does it work? What? Okay, so the question is, why is a vacuum cleaning robot interesting, or why is it interesting IoT? Well, first of all, it has a local user interface, USB console, something, so it can quite often clean without the cloud, but there's a lot of features where you would need the app or the cloud. So, for example, you have this app and it has a local Wi-Fi socket connection, whatever, and then you can do some direct control. So this direct control is really important if you want to run your own shitty vacuum cleaning robot contest or something so that they can fight, I don't know. In the Neato system it's not really useful because this one is not for doing the standard cleaning map whatsoever, but it's funny. And you need it for the first setup with the Beehive cloud. The Beehive cloud is a special cloud that is just there for the user account. So your account in this ecosystem. Then there is a second cloud because everything is better with more clouds. The nuclear cloud. And there's a WebSocket to that you can send robot commands with your app. So if you have a valid Beehive session and so on. And then you can send those robot commands to the robot like clean my house, and then you will also get back a status like yes, I'm on, I'm cleaning, I'm stuck, whatsoever. And everything is better with a third cloud, so there's also this Amazon stuff where maps are uploaded. Yeah, so lots of clouds just for one vacuum cleaning robot. And you might also not really know what is going on in between those because that's nothing that you could sniff. But the remaining parts are very interesting. So recently I realized that it's not just the Neato cleaners, but also the Firmware cleaners. I went to a store to a lady and said, yeah, can you present this one to me? And she really did a nice job with this. And then I asked her, like, wait, what did you say? They get updates? And she said yes, and she was very proud because the old version needed it over USB, and the new one can do it even wireless with this firmware updates. And then I asked her, like, okay, but why does it need a firmware update, such a vacuum cleaner? And then she said, yeah, it gets new functions. Like, for example, you have a map of the floor that is cleaning, and if you want a map of 2 floors, then this is supported by the new firmware, and then you can, for example, like draw a line. So you get a map of your apartment, and then you can draw a no-go line instead of putting this magnet stripe there. So it's kind of useful, but it gets updates. And then I asked her, like, how does it work with the updates? And then she said, yeah, you know, this thing has a CPU, and the CPU gets new functions. Was a bit funny, but yeah, I mean, it's her job. So that's all of the explanation that I got, but it's interesting to see how they actually work. So what is in there? For both those ecosystems, you get a binary for at least those that you can update over USB. And then there's some information about the version and so on, and the hardware model, etc. Then there is a thing that is encrypted and has a certificate attached and so on. And there's also some plain text part, which is the user interface. And then there is a footer, and you cannot flip any byte without getting an error during installation. So there's checksum certificate over everything. It's quite hard to change something here. So everything looks kind of secure here, but at least it's not completely encrypted and you can get some metadata. Yes, and as I said, it's that the CPU gets new functions, obviously. So this firmware update process, I'm going to tell you this now so that you understand what it is for, but it's actually what we reverse engineered in the end. So it's not how we did it, but just to let you understand how it works. So the firmware update contains QNX IFS. QNX is some Unix-like system, but proprietary stuff. IFS is just this file system there, and it's signed and encrypted for a secure boot. And this platform that is running is then, while it's booting, it's decrypting this thing. And even the firmware update process, that you get the firmware update, and then they DD it, encrypted and signed onto the hard drive or flash chip and boot it directly. So during the firmware update process, there's never a state in which you would get a plain text version of this firmware. This actually means that to extract something from the system, you need to break the secure boot in some means. So what I did, I was looking through all kinds of serial ports. So there's tons of ports there, and the only unlabeled port is actually a serial port. This one is there. It's nice because for the new Vorwerk robots, they even have it just as an outside port, so you don't need to disassemble your robot to attach it, but for the older ones, you need to disassemble your robot. And then if you have this USB interface and say some test mode on and then reboot whatever action, you will get an extended boot menu. And in this one, you can say something, it says serial download, but a serial download is not really a download, so you cannot download the system. But what you can do is you can upload a system which is downloaded and then booted, so like netboot. Yeah, so this is pretty useful, but still a problem if you don't really know like what to boot there. So you need to guess, what can I boot over there? And there's this big chip that looks like the main chip, has some weird name, you cannot Google it, you see it's TI, and then there's one thing that you can Google, which is the form factor, and that's for a certain chip family. And then I Googled a bit more if there's like an IFS for this chip family, and what I found is there's some Foundry 27 project, and it's, for example, for the BeagleBoard Black. And for those, there is existing IFS, which you can boot. If it boots, you will get some error, so you will get something and then it breaks during the boot, but at least you can see it starts booting. And at this, so when you are here, and you already like broke the secure boot. So that's the interesting part. I mean, we booted something, it does not boot completely, but we can see we execute something which is out of this secure boot environment. And now the next challenge is that you need to compile your own QNX IFS which boots on this specific platform. But yeah, that's breaking secure boot. Well, so how do you build an IFS? So, well, the nice part is that there is academic licenses, and I asked for one, and then they denied it, I don't know. In a second try, they accepted it, but only for QNX 7, and it's just an awful process. So back then, it was just faster for me that I just download the installer and then hack the license management. And it was kind of easy, and I started it like binary patching in the installer, blah, blah, blah. Pretty annoying, because then I just found out there's an install log, and this install log contains the serial number that you entered, and then is compared, and then says which features is available for this license key and so on. And then I just Googled this format, and then I found other installation keys on the internet. Only problem, they are pretty old, so and that's the thing why this hack does not really work anymore, because what they did is they just disabled the download possibility. So now before you can download the installer, you need to enter a valid license key, and that's the fix which they came up with, even though we did not really contact them on this. I don't know, it was just fixed some time ago. But before you could just download it. It's also pretty annoying because then you need to have your virtual machine set with everything to the old date and so on so that it works. So it's really nothing that you would do in a productive environment. It's really more like a very hacky thing. But it worked to build something. The next part is I wanted to build something that boots on the chip. And I didn't know anything, so there was no documentation for this specific one. And I tried like to initialize, for example, the flash. So my idea was like I initialized the flash and then access the system because I didn't really know that it also was encrypted and everything. But nothing of this worked because everything was mapped to different addresses. The only thing that seemed to be mapped to the standard address was the RAM area. Well, then I was just a bit like, what should I do? What should I do? Well, maybe just reboot and print the RAM area that you can access was my idea. And that's what I did then. So it's very, very slow. What I did is just a reboot, then a for loop that loops over this upper memory area and makes some kprintf over the serial with the slow baud rate and so on, and just prints the memory. Next time when I do this, I might, like, on addition do some, I don't know, base 64 or something. I didn't do anything of this. I just printed, like, characters, and it was pretty slow, but it worked. And then I saw it's, actually I just got 8 times the same thing because of some memory mapping, but okay, so next time it will just be faster, but I extracted the system. So what is done there is basically just a cold boot attack. So you have the original system, you reboot, the RAM is not reinitialized, and I was putting the IFS so my own IFS into a different location than the original Neato IFS, and so I could just kprintf this part into a file. And the funny part is, because it's the system during runtime, it's not just all the binaries that run on it, but in addition it's also stuff like the Wi-Fi password that this vacuum cleaner was configured. So my next idea was to actually boot my own Neato IFS, and it's pretty tricky because the IFS is copied to a certain memory area that is specified in its header. Then it's decompressed, so you need to compress it correctly and so on. Then you have this image directory, which then contains files and so on. Yeah, and that's how it looks like. But the problem here is, so you can actually access everything in it, but if I boot the same thing again into this thing, then there's already the system initialized, and that would mean that you have, for example, stack pointer and everything already initialized, and then you boot again into the same thing with a strange memory state, and this one does not really work, so I don't know. I tried it a few times, but it's also pretty slow because then over serial you upload the system and so on, and then it does not work. So yeah, but whatever. I mean, it would have been nice, but then I didn't continue that because it's just a bit awful to do it. But at least there's funny scripts like Pinky and Brain. So Brain is this main robot binary, obviously, and Pinky is a watchdog. Pinky is pretty awful too because we tried some debugging, so live debugging everything on this robot later, and whenever you crash any process, then the process is restarted and so on, and if the process is not running, it might be that the complete robot restarts and so on, so it's a bit annoying, this watchdog, and the brain is also, it's just calling a bin robot and so on. So yeah, I didn't patch it to the part where I could boot it again, but so what. This secure boot bypass is something that they fixed after the MRMCD, but it took them quite a while until they noticed our talk. So in the end of November, it was pretty funny. I was getting an email from the core developer. I mean, meanwhile, we were already at a point where we were sending them proof of concepts for certain hacks and so on that we had to their support system, and people said, like, we forwarded it to the developers and so on, and nothing happened. And then at some point, I got this email from the core developer who said, hey, oops, can we talk? And just one day later, at the same time of day, I was just, so we were calling them, we prepared like everything, so what were already CVs that we handed in and what is new and so on, and tried to talk to him in a structured manner. And actually he was writing that email during night in California time, and we didn't know that because I don't know who writes mails at 2 a.m., I don't know. And then he also got our call on the following day, like during that time. But he actually like noted everything that we had, and it was really a professional thing because he really noted down everything and they fixed it. But it also takes time to roll those fixes out. So you can see the fix actually in the newest Neato botwag connected D7 update, but not for Forward because they test firmware on the Forward first. And then if it, on the Neato first, and then when it's stable, they roll it out to the Forward. So the cheaper American product is their test platform, so to say, and then the German platform with this better battery, for example, and more sensors, that's then this second platform where they run it. Yeah, and the thing that they said about this vulnerability is that we please do not publish the IFS that you extracted, okay, obviously. And please also do not publish this kprintf for everything that we built to extract the IFS. So, I mean, that's really a rocket science for loop. Please don't do that. So software hacking. Now we had all the binaries, and that's the part when it comes to something that is really more easy to do and more fun, because all the executables there contain symbols and everything, so it's really a fun thing. And even better, there's core dumps. So they have a script running that is really useful. So QNX has some default behavior where core dumps are written to a certain directory whenever a process is crashing. And then this is copied so it's first encrypted and then copied to a USB stick if you attach that and click some things on a robot. So that's pretty useful, I guess, for any developer who gets a robot which is doing weird stuff. So what was the binary doing when it was crashing and so on. But it's also useful for us if we would have the decryption password. So what is the decryption password? Yeah, there's this file called, so there's RC4 crypt. It's a binary, but it does not have any phrase as an argument. Then you can open this one. I don't know, this one is now opened in Gitra, but also it also works in IDA, whatever. This is the password, so 9 characters, special charged, I don't know, but hard-coded. And it's the same for all the series of robots. So so it's, for example, also valid for a very old one, botwag 85 and so on. And it's very nice to see that it's just the same password throughout all the versions, and you can just decrypt all the logs and core dumps. Now the question is, why did I even have a core dump on my robot? So, I mean, I found a core dump and wanted to decrypt it. So why did I find a robot core dump? Yeah, Fabian was testing stuff. So my master student back then, who also now supervised Johannes. So Fabian, he did some testing with the cloud. So he was just sending some arbitrary payloads and checking if anything on the robot crashes. And he thought there would not be a crash because the process is just restarted by the watchdog, so you don't really notice when the service is crashing. And there was this core dump which just contained lots of A's. Who would do that? Or lots of ones, I don't know. Who would do that? Well, it was obviously from this testing. And what happens is this nuclear cloud is sending some command to the binary bin astro, so that's for the cloud connection, which is then executing something on bin robot, and this bin astro is the thing that crashed. And that's the point in time when I said, well, Johannes, can you look into this? This is interesting. And now you're going to hear the second part of the story, how we got control over the vacuum cleaners.
Yes, thank you. So we have this buffer overflow vulnerability, and how can this be triggered? Well, there's this URL highlighted in blue up there, and this is used to send commands from the smartphone app via the Nucleo cloud to the robots. And well, this is used to set up some cleaning schedules or get the robot state or whatever. And well, it contains a serial number of the target robot so that the Nucleo cloud knows to which the request will be forwarded to. And yeah, so here you can see the request, and it contains an authorization header. So one could think that we can only trigger the buffer overflow if we have the key to control the robot. But this is not the case, and we will see in a minute why. And the request body contains the command. Normally there is a JSON object which holds the command, but if this body gets too long, there is the buffer overflow. Okay, so well, now we checked what can we do with this buffer overflow vulnerability. Therefore, we sent a payload with character pattern and analyzed the core dump which was generated. And the registers in the core dump reveal which register we have control over. And yeah, we can control the register R4 to R11 directly, and also the program counter. Well, this is quite promising because it means that we can alter the program flow and therefore execute arbitrary code. So yeah, now we thought, okay, it would be nice to get some command execution on that robot, and let's build an exploit. Okay, therefore we started to analyze the root cause of the buffer overflow, and the link register in the core dump revealed the last function which was called before the process crashed. And the function hmac context cleanup in gray was the last function call, and this function belongs to OpenSSL, the OpenSSL library. So we thought, yeah, maybe the vulnerability is in the Neato code and not in the OpenSSL library. So we checked the call graph to this function, and this call graph is shown here. And we analyzed the function and reverse engineered the function preceding this function call. And well, this vulnerability is located in the red function verify signature. This function name is a bit misleading because it seems that the programmers don't understand this cryptographic concepts correctly, because this function actually verifies and calculates an HMAC. And during this HMAC calculation process, the function or the process crashes, and this is the reason why we can trigger the buffer overflow unauthenticated and arbitrary robots. Yeah, on the right call graph side, you can see the handle of the requests which are sent to the robot via the Nucleo cloud, and on the left side, the requests in the local network are handled. But we cannot trigger the buffer overflow in the local network because another binary receives these requests and forwards it to bin astro via IPC. But the IPC implementation of Neato limits the maximum packet size to 512 bytes, and this is not enough to overflow the buffer. Okay, now let's have a look at this vulnerable function. Here, the orange line shows the vulnerable function call. It's called UTF-8 encode, and it takes an input buffer. UTF-8 encodes this string in this buffer and stores it in a target buffer. And like you can see at the top of this slide, the source buffer is much bigger than the target buffer. And because there are no length checks, well, there's a buffer overflow. Okay, so how is this string built? Well, you can see it in this third last line as in printf. This function takes 3 strings and concatenates them. First, there is the robot serial number, then the date header of the command, of the request, sorry, and the command itself, which is transmitted in the request body. And this means we can control how the buffer will look like, and well, that allows us to build the exploit. Okay, in order to exploit this vulnerability, we have to stick to some constraints. First, the exploit request cannot contain any null bytes, because these requests terminate at the nuclear server and do not reach the target robot. And second, the request can only contain ASCII bytes, because the non-ASCII part of the requests are somewhere cut off in the request processing on the target, and therefore they are not copied into this target buffer. Okay, this makes the exploit development a bit harder, but on the other hand, the exploit mitigation mechanisms by the operating system are not activated. In QNX 6.5, the ASLR and DEP and stuff like that are not activated by default, and Neato did not activate them, and so they are not in place. And stack canaries and other stuff are also not activated, so this makes our life a lot easier. Okay, so we build a return-oriented programming exploit, and yeah, our target is to execute the libc function system, which allows us to execute arbitrary system commands. And in order to do that, there are 3 steps. First, we have to place the command, which will be executed on the stack of the process. Afterwards, we take the address of this command, place it in R0. R0 is the register which holds the first parameter of a function call in the ARM architecture. And yeah, finally, we call the function system. And we do this utilizing the corresponding ROP gadgets and chain them together to a ROP chain. Okay, well, the problem is that the address of the command string on the stack and the address of the system function do not stick to these constraints I explained before. So this means we cannot transmit them in the exploit request directly. So to solve this issue, we just transmit requests which stick to these constraints and use an add gadget to add those values and to generate arbitrary addresses. And this allows us to generate these addresses and call the function. Yeah, but the addresses of the ROP gadgets have to stick to the constraints because they are also transmitted in the request. Okay, so what does this mean? Well, the exploit allows to execute arbitrary commands on arbitrary robots, unauthenticated and with root permissions. So, well, this is quite bad because you can do basically anything with this, and you just need to have the serial number of the robot, because the cloud needs to know to which target the request needs to be sent. And well, that's not so hard to get, because the serial numbers are printed on the robots and on the packaging itself. You can just go into a shop, check out some serial numbers, and attack arbitrary robots. So yeah, so what could an attacker do with this exploit? Well, you just can predict some robots and annoy the users, or yeah, you could attack further devices inside the local network, which would be protected by a firewall otherwise, which is quite bad. And yeah, you could use it to build a botnet and to start some DDoSing or Bitcoin mining or whatever. Or yeah, you could extract some privacy critical information from the robots, like floor maps or other sensor readings, which is also quite bad regarding the privacy of the users. Okay, some final words to the responsible disclosure timeline. Well, we started to contact them back in March 2018, and our first responsible disclosure attempts terminated at the first level support because they just not forwarded them to the responsible developers. So at some time we just sent them the exploit in the email, and well, they just closed the ticket and did nothing. And yeah, so we didn't know what to do. But finally, we got the contact in November 2018, and the developers were quite cooperative and communicated with us like Jiska said before. And yeah, the fix itself was quite easy because they just had to implement a stricter length restriction on the server side. And they additionally implemented some mechanism to check the HMAC so that you cannot send requests to arbitrary robots because you need to know the key, the shared key. So yeah, they fixed it quite good, quite fast. And yeah, now the robots, the robots are safe. Okay. Thank you.
So, first a question from me to you. Who of you has a vacuum cleaning robot, no matter if smart or not? Ah, interesting. So there might also some of the hands that were rising who now have questions to us about their robots, I don't know, about their privacy. Nobody is concerned or wants to know more? Yes, Dave. Just wait a second for the microphone.
You already asked the question yourself why they do need a software upgrade, but why do they need all these cloud connections? What is the reason for this? They connect to your local wireless LAN, so you could directly control the robot, not via some
yes, so normally you could do that, that's true, but they don't. I guess that some features like drawing these no-go lines in the map are harder to implement if you don't do it with the cloud. And the next problem is it just would be in your local Wi-Fi. And customers want features like, oh, my friend is visiting, so I start the robot now, and when I come home, it's clean, so they want to do it remotely. And then it's easier to implement like just one interface, and then it's via cloud. So it would probably not be needed, especially not for the nerds of us who have their VPN to home anyway. But it's very convenient, I guess, for the average customer. Yes, next question.
Are you aware of any vacuum robots which do not come with all this cloud crap?
So what you can do is actually that you can use this vacuum cleaner without the cloud, and then it just cleans. So yeah, it just cleans. You press a button and it cleans. And also a nice thing is, so compared, for example, to Xiaomi, that robot is then, it seems to stop broadcasting this Wi-Fi. So you cannot take over a robot that is unprovisioned. You can just use it without the cloud, but then you could also probably buy a cheaper model. At least they are very good in cleaning, I would say. So they have a good power and are very efficient, and they have this deform to go into corners and so on. So there's reasons to buy this special kind of robot and then just not to connect it, but also might be a bit too expensive then. So 2 questions, great. Is this a follow-up question, any of this? No?
Can you tell a bit more about the Firmware model? Is it like the same hardware and the proven firmware, or is it a different hardware?
It has rainbow-colored LEDs. No, I mean for real, but not only this. So, so first of all, there's a brush. So on both models, there's a brush in the front to go into the corners, and it has some ultrasonic sensor to the side so that it does not bump into the wall.
Okay.
But for the Firmware model, it also has 3 ultrasonic to the front, so that it's also not bumping to the front. And they come with a different battery. Mm-hmm. And the Firmware model has better, I would say, more efficient power settings. So the eco mode is more eco, and the power mode is more power. And I feel in the Neato, it's just, I think it's 50 versus 60%. of the maximum power, and I think in the Vorwerk it was a bigger difference, like 50 to 75 or something. So you really have a powerful mode and an echo mode.
Okay.
And I also feel that those Neato models are a bit louder due to that. So when I was in the Vorwerk store and they showed it to me, they were just running it in echo, and that was more silent. Yeah, so there is some differences. There's a reason why the Vorwerk is more expensive, I would say. It also felt better somehow. It has a green brush, obviously. Yeah.
So do you think Vorwerk did their own research and just bought the IP of an existing model to make a better robot? Or did they buy the whole thing and just rebrand it as Vorwerk?
So I think they, I mean, they run their own cloud, so it's the same cloud but with different names. And they acquired Neato some years ago, 2017. And before, I guess they also did development together.
Okay, thank you.
So the next step would be to build an alternative firmware. Did you do any steps in that direction? Is it possible to disable the secure boot and boot something else, or say with JTAG or something, or is this completely out of question?
Yeah, so the problem is that the serial boot is not that fast and so on. So we were thinking of one alternative. So there's so the fun part is while we were stuck in communicating with Neato, there were some other hackers who also did something with the Neato robots in an older version, and there was a bug in some NTP time setting command where you could inject something during runtime, and that would be better. So you boot the system and then do the modification over this vulnerability, and that would be probably doable with your Raspberry Pi in a local network. So that would be a variant, I think. So especially for those where you need to open the casing and everything to attach cables, that's not really something you would do. Yeah, I don't know, but I think it's more convenient to have just a Raspberry Pi and a certain network config, and then the robot is exploited locally. But that exploit only works on older versions, also not over the cloud and so on. Yeah.
How did you get the contact to the Neato developers finally, and what did they say exactly, besides the support just closing the tickets?
So that at some point, so when we got that call, this developer or software lead, he already had seen our MRMCD talk. So someone said to him, oh, it seems to be something serious. There has been a talk, and he was well informed and contacted us in the end.
And what was the reaction afterwards? Was he happy or thankful or?
I would say they were a bit confused, like why we chose their system and so on. I mean, it's interesting. They have interesting technology, right? And also are, like, at least in Germany, something you would buy. They were at least happy enough to send us one model for testing. We needed more for testing, and I think we are like at the border of what Amazon Business allows you to buy and send back. Yeah. So there's, I don't know. So our secretary really hates me now. So whenever I say, it might be, don't pay it yet, we might send it back, she has always this face, and then she says, like, vacuum cleaner. Yeah.
Thank you.
Then thank you for listening.